Okay, first of all, let's have a look at some of the solutions of the homework in topic 3. Okay, first one is part 1, question number 2a. Okay, simplify each of the following expressions. Okay, we can combine the like terms, right? So this gives us, we can write all the terms that includes AB together, 3AB minus half of AB, and minus AB, right? And plus negative 4CD plus 2CD, and then plus all the constants. We can put all the constants together, right? So eventually this gives us 6AB over 2 minus half of AB minus 2AB over 2, right? Plus or minus 2CD, then plus 13 over 3. And that can be simplified to 3AB over 2 minus 2CD plus 13 over 2, right? Did you get it? Okay, and then question number 2D. Yeah, I can see some of you have done this correctly, but others didn't. So let's have a look at the solution to this question. Again, we can try to factorize each of the fractions. Okay, so this gives us 2 times x plus 2y, right? Then times, okay, we can write the 3xy here, and then 8 times, we can put x here. Then next we can cancel some of the terms. Cancel a 2 here. So this gives us 4. And also we can cancel this. Cancel a x here. So eventually you will have the expression 3y over 4, right? Okay, next one. Again, the method should be the same. So this is basically equals 2 times, we can put 3 in front, and then times 9a in front, a squared minus 2b here, right? And times 10a squared. And eventually this can be simplified to 3 over 5a. Did you get it? Alright, so next, question number 3a. Write the following expression as a single fractions. Okay, so we need to use a common denominator, right? The common denominator is usually the least common multiple of the first one and the second denominator. So we can use 18a squared b squared as a common denominator, right? Because 18a squared b squared is the least common multiple of the first and second denominators. So if we convert the first fraction using the denominator 18a squared b squared, you need to multiply a 3a here, right? Plus, if you rewrite the second fraction using the denominator 18a squared b squared, then we need to multiply the numerator with a 2b, right? Therefore, we have 6a plus 3a squared plus 18b minus 2b squared over the common denominator now is 18a squared b squared. You get it? Okay, question B. Okay, again, if you need more time, just let me know, okay? Otherwise, I'll just jump to the next one. Okay, and in this question, the common denominator is, well, if you rewrite this using the factorized form, you can see that's actually 2r times r minus x, right? So this denominator is r times s minus 1. Therefore, probably we can try to simplify each of the fractions first. So put 8 there, then 8 times r minus s over 2r times r minus s, right? The second one gives us 3r squared over r times s minus 1. And we can cancel r minus s here, cancel a r here. So that gives us 4 over r plus 3r over s minus 1, right? And the least common multiple of r and s1 is r times s minus 1, right? And the numerator becomes 4s minus 4, then plus 3r squared, right? Okay, and next let's have a look at question number 4. Solve the following equations for x. Okay, if you need to solve for x, we treat any other letters as constants, right? So we can combine all the terms with x together. So that's a plus 2d squared x equals 3c minus bc, right? Then you need to do some casework. You can't just divide both sides using this number here because it could be 0, right? So case 1, if a plus 2d squared equals 0, and at the same time 3c minus bc is not 0, then the left side is always 0, the right side is not a 0, right? Therefore, there is no x that can satisfy this equation. In this case, there is no solution. You follow me? Case number 2, if a plus 2d squared equals 0, and at the same time the right side is also 0. Then we know as long as x is a real number, the left side is 0, the right side is 0, so the solution is any real number, right? X can be any real number, so x belongs to the real number set. This is a solution. You get it? And there is another case, of course, case number 3. If a plus 2d squared is not 0, then we can divide both sides using this number here, right? And then in this case, the solution is x equals 3c minus bc over a plus 2d squared, right? You see that? You need to discuss different situations here. So depending on whether a plus 2d squared is 0 and 3c minus bc is 0, we have 3 solutions. Any questions? And you can use the same method to find solutions to the next question B. Method should be the same, okay? So we'll just move to the next question, number 5. Evaluate this expression when x equals negative y. So when x equals negative y, we can substitute x using negative y, right? So this gives us 4 times x squared becomes negative y squared, right? And minus 2y, you can just keep it there because we want to substitute all the x with negative y and keep all the y's there to see if we can combine some like terms. And minus 2 times 2y squared, then plus 4x is plus 4 times negative y. Remember, x is negative y, right? And plus 2. Then expand everything. We have 4y squared minus 8y plus 28, then minus 4y squared, and plus 8y, then minus 4, right? And we can cancel 4y squared here with negative 4y squared, negative 8y with plus 8y. So this only leaves us 28 minus 4, which is 24, right? So the result is 24. It's a number. Okay, next one. By what fraction can we multiply 3x cubed over 2y to the power 5 to get 6y squared over 5x squared? Okay, suppose we let's use letter A denote the desired fraction. So according to the given information, we know that if we multiply 3x cubed over 2y5 with A, you will get 6y squared over 5x squared, right? So in order to find A, you need to divide both sides using 3x cubed over 2y to the power 5. So A equals 6y squared over 5x squared divided by 3x cubed over 2y to the power 5. And this equals 6y squared over 5x squared. Remember, if you divide some fraction, that equals to multiply the reciprocal of that expression. So that is equivalent to, say, multiplied by the reciprocal of that expression, which is 2y to the power 5 over 3x cubed, right? And we know that equals, of course, you can cancel a 6 here. That leaves us 2 here. So that's 4y to the power of 7 over 5x to the power of 5. So that is the required fraction you are looking for, right? You follow me? All right, then number 7. Okay, if x equals a over b, a is not b and b is not 0, then express a plus b over a minus b in terms of x. Okay, we can say because b is not 0, x equals a over b, right? Then we know bx equals a because we can just multiply both sides using b because b is not 0. And we can insert, let's call this star, insert expression star into a plus b over a minus b. Then we have a plus b over a minus b equals, a is a, just keep it there. Oh, sorry, a is bx, right? Which is here. A is bx, so we can substitute a using bx, so bx plus b over bx minus b, right? Apparently that's a b times x plus 1 over b times x minus 1. So cancel a b here because b is not 0. That gives us x plus 1 over x minus 1. So this is how you express this expression in terms of x. We only have x in this resultant expression, right? Can you follow me? Okay, again, if no questions, let's move on to the next one. For what value of a does the equation 1 over 1 plus the reciprocal of x equals a have no solution for x? Okay, we can actually try to solve this equation in terms of x, right? So let's say the equation is star. Equation star is equivalent to x over, okay, that's right, one more step here. So 1 plus 1 over x is x plus 1 over x, right? So if this equals a, then this is equivalent to, say, x over x plus 1 equals a, right? Which is equivalent to say x equals a times x plus 1. And we have x equals ax plus a. Then 1 minus a times x should equal a, right? So we have 1 minus a equals 0, which means when a is 1, there is no solution, right? Because when a equals 1, the left side is 0, the right side is 1. No matter what x is, the left side cannot equal the right side. So there is no solution for x, right? And otherwise, if a is not 1, we have x equals a over 1 over a, right? And however, x is not 0. And we also know 1 plus x over 1 cannot be 0, right? Because x in the position of denominator, 1 plus 1 over x is also in the position of denominator, which means x cannot be 0, and x cannot equal -1, right? So we can actually let let a over 1 minus a equal 0, and this gives us a equals 0. So if a is 0, we do not have any solution either, right? And we can also let a over 1 minus a equals -1, and apparently there's no solution for a. So we can see that when a is 0 or when a is 1, there is no solution for x, right? Okay, again, there are two possibilities there. One is when a equals 1, there's no solution for x. Second is when a is 0, there's no solution for x as well, right? Any questions? Okay, if not, let's have a look at part 2. Okay, evaluate the following expressions when x equals 2, y equals -3, and z equals 4. So the method should be pretty straightforward. You can just insert the 3 values into each expression, right? For example, the first one equals 2 by 2 minus 3, then multiplied by 4 minus 2, right? Over 2 times -3 squared times 4, and this gives us 2 over 2 times 9 times 4, and eventually we have 1 over 36, right? Okay, let's do another one here. Again, just insert x, y, z there. That gives you 2 minus 4 times square root of -2 times 2 times -3. Apparently we have a positive number and there's a square root symbol. So we have -2 times square root of 2 square times 3, right? So we have -4 times square root 3, right? For the other questions under question 1, the method should be the same. Just insert x, y, and z there and evaluate each of the expressions. So I'm not gonna do the rest of the questions. Okay, and for question 2, simplify each of the following expressions. Again, the method should be the same with the questions in part 1. For the first one, we can use the formula a squared minus b squared. This is a plus b times a minus b, right? Of course, if you don't know this formula, you can also expand the first one and expand the second one, and then we can actually cancel the x squared and y squared, right? For example, if you expand the first one, you will get x squared plus 2xy. If you expand the second one, you will, sorry, I lost a y squared here. Then if you expand the second one, you will get x squared minus 2xy plus y squared over 4xy, right? So we have 4xy over 4xy, which gives us 1, right? And again, for the other questions under the second question, the method should be the same. Just try to factorize each of the expressions and cancel any terms that is the same. Then you can simplify each of the expressions. Okay, if you haven't done them correctly, try to correct them by yourself after class, okay? And for the third question, rewrite the following expression as a single fraction, simplify if possible. Okay, let's do question A only, okay? So again, the least common multiple of these two denominators should be 6x squared and y, right? So we can rewrite the first one using this denominator, so 5y times y minus 4 times, well, if you use 6x squared y here, then you need to multiply the numerator using 2 times x, right? So this gives us 5y squared over 6x squared y minus 8x over 6x squared y. Then you will have 5y squared minus 8x over 6x squared y, right? You follow me? Again, if you haven't done each of the questions correctly, try to correct them after class. Then question number 4c. Solve the equation in terms of x. Okay, this question C is a little complex, so let's call this equation as star. So star is equivalent to, by equivalent I mean the new equation should have the same solution with the original one. So first of all, x cannot be 0, right? Because x is a denominator. And then if x is not 0, we have a plus bx minus cx is 0, right? Which is equivalent to say, first x is not 0, and then c minus b x equals a, right? Therefore, you need to do some casework. First, if b equals c and a equals 0, then we know the solution is x belongs to the real number set, which means x can be any real number, but x cannot be 0. And second, case 2, if we have b equals c and at the same time a is not 0, so you need to consider this equation here. The left side is 0, right side is not 0, right? Therefore, no matter what x is, this equation cannot be true, so no solution for x. And case number 3, if we have b does not equal c and at the same time the right side is 0. That means x must be 0, right? But here we know that x cannot be 0. So basically you have a solution which says that x cannot be 0, but x must be 0. This is not possible, right? Therefore, in this case, we have no solution for x as well. And last case is if we have b is not c, b is not equal to c, and a is not 0 as well, then we have x equals a over c minus b. We can simply divide both sides using c minus b, right? You follow me? Alright, then let's see next one. Question number 9. Again, we have already talked about similar question in previous part, right? Suppose we let letter A denote the desired fraction you are looking for. Then, according to the given information, 3x cubed over 2y5 to the power 5 times A equals 6y over 5x, right? And this gives us A should equal 6y over 5x divided by this expression here, which is equivalent to multiplied by the reciprocal of it. Then simplified to 4y to the power of 6 over 5x to the power of 4. So this expression is the one you are looking for, right? Okay, so basically these are the questions most of you haven't done correctly. And if you have any other questions, please let me know. I'll explain them here, okay? Otherwise, we'll start to learn today's new contents. Sounds good? Okay, I'll give you 2 minutes to have a look at these questions. Okay, any questions, just let me know. Alright, if you don't have any questions, this is the solutions to the homework of topic 3.